Okay, so here's a short video to hopefully better explain ionic radius. Okay, so let's take a look. Here what we have is, this is a representation of a lithium atom. Okay, we know it's lithium because I see that we have 3 protons and we have 3 electrons. Now, if you look on the periodic table of elements, the element with the atomic number of 3, which represents the number of protons, is lithium. So what I'm going to do here is I'm going to go ahead and just write right up here. I'm going to write lithium. So this is my lithium element. Okay, it's my lithium atom. Now, what we're going to talk about today is the ionic radius. In order for us to understand what exactly is ionic radius, we have to understand 2 things first, okay? We have to understand first atomic radius, okay, which is the distance from the edge of the nucleus to the edge of the electron cloud, and we have to understand what an ion is, okay? So we'll take a look at both of those things today. But let's start real quick with ionic radius. With atomic radius, excuse me. Atomic radius is the distance from the nucleus of the atom, which is here, okay, from the edge of the nucleus to the edge of the outermost electron cloud. So basically this distance here, and you can think of this kind of like the distance, the radius of a circle, is the atomic radius. So let's take a look. Let's write atomic radius right here. Atomic radius, okay? So make sure you're writing this down. So that distance represents your atomic radius. Now, in order for us to understand ionic radius, we have to know what an ion is. Okay, so let's take a look at lithium one more time. Lithium exists with an atomic number of 3, which means it has 3 protons, right? Now, protons carry with it a positive charge. Because they carry with it a positive charge, that's why you see this positive right here, okay? Now, with every positive proton that it also has 3 electrons. Okay, now electrons carry with it a negative charge, which is why you see this negative right here. So if we take a look, 3 protons and 3 electrons is the same thing as saying 3 minus 3, okay, which gives you 0, right? 3 minus 3 gives you 0. So lithium in its natural state carries no charge, right? It's neutral. Now, when an ion forms, what happens? Okay, well, what happens in an ion is that one of these electrons, right, the one on the outermost energy level, gets given away, right? It goes to an element that better needs it. So let's take a look. I'm going to draw a little arrow here to represent that this electron gets donated. So there it goes. Okay, so what's happening here? Let's take a look at it in just really simple terms, okay? I'm going to write lithium right here, okay? Now, we know that lithium has 3 protons, 1, 2, 3, right? And for every proton, it has an electron, right? So 1, 2, 3 electrons. 3 minus 3, like we said up here, is just 0. Here's what happens. If lithium has those 3 protons, right, and it gives away one of its electrons, well, it's 0 here. It's 0 here, but if you look, you end up with +1 here. So what happens is you end up with lithium +1 because it doesn't have that negative electron there to counter out or to counter that positive proton. So you end up with a net +1 charge. Now, you might be thinking, well, what about the protons? Well, you can't change the number of protons, remember, because the protons determine what element you are. If you change protons, then you're no longer lithium. But lithium can give away one of these electrons, right? The valence electrons, to be specific. Now, we know, or if we should know, right, that between positive and negative, there is an attractive force, right? They're kind of wanting to go, these protons are kind of pulling in these electrons a little bit, towards the nucleus, and it's kind of like what keeps them in orbit, right? It's that positive and negative attraction that brings in the nucleus, or that keeps the electrons, in orbit around the nucleus of the atom. What happens though when you have one less electron, but you still have the same number of protons, right? So let's draw that real quick. I'm going to draw my protons here. Let's see, I'm going to see if I can get a similar color. I'm going to draw my protons here right in the middle. 1, 2, 3, right? Now we know that protons are in the nucleus, so they do have a positive charge. I'm not going to write that in, but we should know that they have a positive charge. Now on the outside, right? On the outside, I'm going to draw my electrons. Now remember, we have one less, right? One less electron. So I'm just going to draw the ones here on the outside. All right, so there we are, right? Okay, now what's going to happen here? Okay, so I cleaned it up a little bit, just took some of the stuff out of here. I got one more thing here I got to take off. Okay, now keep in mind that now we only have 2 electrons, okay? So what's happening here is that these 2 electrons are feeling a lot bigger pull from these 3 protons. And what ends up happening is that this electron cloud shrinks down to size, right? Because now you have a greater pull pulling those electrons closer to the nucleus. Your radius actually begins to get smaller. Okay, so I'm going to show that to you here. Let me just get the right color. Now the distance from the edge here, oh, too thick here, from the edge here to the edge here is actually shrunk, right? Now what's happened here is that lithium has given away one of those electrons, remember? So because it's lost an electron, now it's formed an ion. The name of the ion that we have is called the lithium 1 plus ion, right? And because it is a positive ion, this is what we call a cation, a positively charged ion. Now, because this is now an ion, it's no longer just an atom. This distance here, the one that has shrunk, is not called the atomic radius anymore. It's now called the ionic radius. Okay, so now you have an ionic radius. So what's the trend on the periodic table? Well, let's take a look at the positive ions first. In a cation, the radius or the distance from the nucleus to the edge of the electron cloud shrinks when you form a positive ion. And that shrinks because these 3 protons are pulling in these 2 electrons a lot tighter than they were before. So because they're pulling them in closer to the nucleus, what's happening is that this electron cloud is actually beginning to shrink. It's beginning to constrict and move closer into the nucleus. And when that happens, you have a shorter ionic radius compared to what you have here. Okay, so in a cation, or a positively charged ion, you see a decrease in the distance from the nucleus to the edge of the electron cloud, meaning that your ionic radius decreases as you become positively charged.